Hello everyone. In this video we're going to go over the problem number 4, or the second actual problem on the final exam, the red-black tree question. So part A says step by step build a red-black tree with an ordered input sequence of, and then it gives the sequence. So we're just going to start right out. I also want to say, we're supposed to give it, or we're showing the step by step to go to red-black tree. Just because I say step 1, step 2, step 3, those aren't the only steps. There's steps within step 1, but I'm just kind of inserting each of those elements as like the main overall step, and there's steps within there. I just want to point that out. So for step 1, I have I just kind of show 20 by itself. I hope that's all right. But so we insert 20, and then so we only have one node, and then I showed a picture of inserting 5. So 20 is in the red-black tree. 5 comes along, is compared with it, and we know that it's less than. So the 5 moves down the left subtree. And it's evaluated that there's nothing there, so 5 is inserted as a red node, as always, in a red-black tree to the left, in the left subtree of 20. So step number 2, we're going to insert 11. So again, 11 is first compared with the root node, which is 20, and it's less than. So then we move on to the next node, which on the left subtree, which is 5. And we know that 11 is greater than 5, obviously. So then it moves down the right, because it's greater than, it moves down, greater than or equal to, it moves down the right side of the subtree, and it sees that there's nothing there, so it gets inserted there. Now we have the issue of the node. As always, when you're inserting, it's red. We have 11 is red, and the node above it, or its parent, is red, which we know that violates the red-black tree kind of policies. So we have a parent and a child node that are both red, as you see in this picture. I'm going to go ahead and swipe up now. So in the top left is where we're at. So at this point, what we do, like I said, sorry, on the last slide, I kind of say it again in the text. The parent and the child are both red. So we do what is called a rotation, and we do a single rotation to the left. So 5 moves down to the left, 11 moves up, and again, as we said, we still have the same issue we had a minute ago. So with a parent and a child being both red. So now one more single rotation to the right this time should fix the issue, and it does. We see that 20 moves down to the right, the black moves back up to the root, and we have a perfectly fine red-black tree. So step 3, insert 10. So this is the way I'm going to pretty much start out every time, just because I want to make sure I go through every step. It may seem like I'm kind of repeating myself, but it's just to make sure someone who doesn't understand understands. So we take 10 and we're going to insert it into our subtree. So first we compare it with the root node as always. 10 is less than 11, so 10 is going to go to the left side, down the left subtree, where it reaches the red 5. It is then compared to the red 5, and it is greater than, so that means it greater than or equal to, so it moves down the right side. And it is inserted to there in the right subtree of 5. So now we again have a red child and a red parent, as well as what's known as a red uncle node, which is the red 20. So the first thing that is done is we make the 2 children of the root node. It's called pushing. We push the black down the tree. So the 2 children of the root node become black. And then we have a red 10 at the bottom. So everything, all the policies of red-black tree are then met. So next we're going to insert 29. If we look right above, I'm showing this is still the tree that we're inserting in. So 29 is greater than the root node 11, so it moves down the right subtree. So then it is evaluated again against 20, and is since 29 is greater than or equal to, it goes to the right subtree of 20, and is inserted there as a red node. And at this point, all RB tree criteria is met. So I got a picture of that on the next one, and it's in the top left. We don't have to do any rotations, or we don't have to move any colors down the tree, because, like I said, all the criteria is met for this problem. So step 5, we're going to insert a node with the value 5. So as always, 5 is first evaluated with the root node, and it is less than the root node, so it moves down the left subtree. And then we reach 5, duplicate. Since 5 is greater than or equal to 5, it moves down the right subtree and is less than 10, so it is placed in the left subtree of node 10. So now we have a left child that is red and a right child that is red. So what we're going to do is we're going to rotate once to the right. That's shown in the picture on the top right. And this gives us a red parent, which is 5, and a red child, which is 10. So now we rotate once more, but this time we rotate to the left, and we change the color of 5 to black, and all the criteria of the red B tree is satisfied. So like I said, so basically on the top right of this page that I'm showing you, we have 5, black, red 5, and then down the right side red 5, and then a red 10. And then we move to the next picture where we do the rotation to the left this time, and you can see that we have everything is fine in this red RB tree, so we're ready to move on. So step 6, we're going to insert 9. So as I do in every step, 9 is first compared to the root of the tree and is less than to the root, so it's going to move down the left subtree. And then it comes to the black 5 where it's evaluated and is greater than. So then again, it's going so now it's going to go down the right side of the black 5 subtree and be evaluated with 10, the red 10. And since 9 is less than 10, it's inserted in the left subtree of the red node 10, shown in the picture on the top left now. So now we have a red child and a red parent. So as we've seen, this is an issue. Now we do see that so what happens is that the black 5 pushes the black color down the tree, and now all the criteria of our RB tree is met. So step 7, insert 21. So 21 is first evaluated at the root node. Since it is greater than the root node of 11, it moves down the right subtree and is evaluated with 20. 21 is greater than 20, so it proceeds down the right subtree of 20. Next, it is compared with 29, and we know that it's less than, so it's going to be inserted there on the left subtree of node 29. Now, as you can see, there's once again a red child and a red parent. So we rotate once to the right, and once again we have a red child and a red parent. So now we rotate once more to the left, and this satisfies all the criteria of the RB tree. We have a black 21, a red 20, and a red 29. So step 8, we're going to insert 4. 4 is first compared with the root node 11, and it's less than, as we know, so it moves down the left subtree. Next, it's compared with the red 5, and it is less than, and then it moves on to the black 5, and it is less than. So now we just insert it in the left subtree of the black 5, and this one, as shown in the top left picture, we don't have to do anything else. We have a red child and a black parent, so we are good to go. So step 9, insert 15. 15 is first evaluated with the root node 11, which is greater, excuse me, which is greater than the root node, so it proceeds down the right subtree, where it first hits the black node of 21, which we know that it is less than, so it moves down the left subtree of 21 to the red 20. it is then checked with the red 20, which is less than. Therefore, it can be inserted in the left subtree of 20. Now we have a parent and a parent 20 and a child 15 that are both red. It also has an uncle node that is 29 that is red. So the grandparent node 21 pushes black down the subtree to satisfy the colors shown in the picture in the top right, which now our B trees met. That is the last insertion. So moving on to the part B, I'm going to go ahead and go into that too. I hope that's all right. So this is a very similar tree. I think I want to say, let's see here. I want to say that this is a very similar tree. Moving on, we first see that, so we want to delete the red node 21. So first off, I kind of just have a picture of, I'm pretty sure, let's see here. So before I turn this in, I will make sure. It looks like I'm missing the red 9 node in this picture. I apologize for that, but thankfully it's not used in this given problem. So because it's in the complete opposite subtree. So first, so we want to delete node 21. Node 21 has two children, 15 and 29. So the first step is to find the largest node in the left subtree. As you can see from the picture, the largest one is going to be the red 20. So now that we have found it, now that we found the largest node in the left subtree of the one we want to delete, we take that value and copy it into the node that we are deleting, which is 21. So I have a picture on the top left over here. So we've, I know you can't see my mouse, but where 21 was, we've taken 20 and copied it into it. And then the next step, which I will show here. So the final step of deleting is we're just going to remove the bottom red 20, that where 20 was. We're just removing that node because it has moved up where the red 21 is, where the 21 was, and now we have deleted that node. And that is going to be it for problem number 2. Thank you guys for watching.